This video presentation explains how the multiple regression term project is to be carried out. It also shows an example of a completed project and Purdue Purdue University Calumet. First, the description of the term project. It says here that this is an individual project on multiple regression. You may also choose to perform a multi-way analysis of variance ANOVA, but I suspect that you do want to make it a multiple regression project though. If possible, your project should draw from your work environment or career interest, but note that this is not required. Begin by identifying a response variable, that is, your dependent variable, the y variable. So this is key, and this is why I've highlighted this for closer attention, because the dependent variable is the problem that you wish to study, that you wish to examine in this analysis. And then afterward, you can think of two or more independent variables you believe may help explain the variations, or if you like, the behavior in your chosen response variable, in your chosen y variable. So you're going to have a minimum of two independent variables for this to be a multiple regression project. It says here also it is preferable to use cross-sectional data instead of time series data, that is. Remember, cross-sectional data refer to observations of many different subjects or objects at the same point in time. On the other hand, time series data are generated at successive points over time. Now then, if you choose to go ahead and use time series data, that's fine too. This, after all, is a learning process, so it doesn't really matter in the final analysis whether you're going to use cross-sectional data or time series data. It's just that time series data does have certain problems regarding the way the data are generated. Some of them have to do with residual correlation and much more extensive ways of correcting those problems. In any event, here I say that examples of areas of study that may offer researchable ideas include the following: labor problems. For example, you may be interested in learning something about worker productivity, why that changes from time to time, or from firm to firm, or from industry to industry. The next example here is corporate performance. One might be interested in learning about variations in firms' operating income. This one here, market analysis. You might be interested in learning about market share of firms. Next, accounting and internal control. You could be interested in learning about the cost of independent audits of firms. Supply chain, perhaps delivery time might be an issue of interest to you. Consumer behavior, perhaps one might be interested in studying brand loyalty. Social and political issues. One might be interested in learning something about opinions and surveys and approval voting of citizens of a particular community. International trade. You could be interested in studying current accounts balance and why you have deficits and surpluses at different times and across different firms, across different countries. Education reform. One might be interested in learning about student performance. And these are just a few of ideas that I'm throwing out there. Now, as far as your project is concerned, I've simplified the process for you. There are 4 sections to deal with. Section 1, Introduction. Section 2, Data and Methodology. Section 3, Analysis and Results. And the final Section 4 deals with conclusions and study limitations. Now then, for Section 1, it says to provide a brief background of the study. What's the study all about? What is the significance of the study? Are there possible benefits that may come out of the findings? If there are any background studies, cite them here. And it says maximum half a page. And by the way, these are all going to be maximums. A couple of sentences are sufficient. This is a term project, not a term paper. So the intent here is to concentrate on the statistical analysis and not on an extensive write-up. So this is what I've done as an example of introduction of a study. So, and as I've mentioned up here, you begin by identifying a response variable. My interest here is to learn something about education reform. Specifically, the Y variable of interest to me is student performance. So I'm going to begin by identifying a measure of student performance. And in this example that I'm about to show, my measure for student performance is going to be the mean score on the Massachusetts Comprehensive Assessment System, MCAS, which was administered in May 1998 to 10th graders. So what I've done is to look at the 224 school districts, and for each district I collected the average performance score of for this test, and then correspondingly I considered factors I believe might help explain variations in student scores. And for this study I've specified 4 independent variables. The first, student-teacher ratio. The second, teacher's salary, the average teacher's salary. The third, household income. And the fourth one is the percentage of single-family households. So now, for example, for district number 1, the average student score is 227. The student-teacher ratio is 19. The average teacher's salary is $44,000. The average household income is about $48,8900. And finally, the percentage of single-family households here is 4.7%. In the same way, I obtained the corresponding data for the rest of the districts, as you see here. So now, I'm ready to rock and roll. So, as an introduction, I said here, this study, first off, this is the title of my study, a regression study on the impact of socioeconomic factors on student performance. Now I write here that this study seeks to determine if a relationship exists between student performance and a set of socioeconomic factors. These factors include class size, school expenditures, and family background. The outcome of studies such as this may help identify which factors policymakers should consider when working on improving educational standards. So, from your term project standpoint, this suffices as an introduction. However, since I'm trying to teach you a comprehensive process of approaching studies such as this, I have a little bit more to contribute. So I further write as follows. Education reform remains one of the most hotly debated national issues. There is a recurring evidence that American students perform poorly in reading, mathematics, and science when compared to their peers in other countries. In 2013, for example, the Organization of Economic Cooperation and Development, OECD, published the results of a comparative study of mathematics and science skills among 15-year-old students in more than 60 nations and school systems. In mathematics, the US ranked 26th. The rank was 21st in science. And so here, you can see the footnote there. That's it right here. Alright, this footnote. And if you went to it, this is what you will find. Alright, and when you click on this, you'll get more information about this particular study. And then continuing here, I wrote, there are almost as many reasons for this apparent failure of our public education as there are pundits who are willing to discuss it on national television. Poor teacher preparation, intransigence of teachers' unions, poor parenting, and insufficient funding are some of the reasons given for this problem. At the same time, there is a counter-review documented by the American Federation of Teachers which argue that the lack of early childhood education and poorly targeted resources are some of the contributing factors. And for this, I supplied a footnote as a reference. And if you went to it, you will find this information, which actually is an interesting video that you could play and learn more about what they refer to as the 5 myths about our schools that fall apart when you look closer. A little bit more here. It says at the federal level, some efforts have been made to reform public education and improve student performance. Most notable were President George W. Bush's 2002 No Child Left Behind and President Barack Obama's 2009 Race to the Top. The former law required states to give students in grades 3 to 8 an annual test in reading and mathematics. Among other things, Race to the Top rewards states for implementing performance-based standards for teachers and principals. Unfortunately, reforms such as these have yet to produce the intended results, which is to raise the proficiency level of high school graduates. This study, the one I'm about to perform here, does not seek to explain any factors believed to contribute to student performance. Rather, it simply attempts to investigate if a relationship exists between student performance and a set of socioeconomic factors often mentioned in the press as contributing to student performance. The method of analysis is a multiple regression. So, now continuing to section 2, data and methodology, it says describe your data and regression equation, show the statement of hypothesis, define the variables, and what manner of relationship do you expect to find. This is very important. So here we're going to go to my section 2 and see what we have. For data and methodology, I write that empirical data for this study were obtained from 224 school districts in the state of Massachusetts. The response variable y is student performance and is measured by the mean score of the Massachusetts Comprehensive Assessment System, MCAS, administered in May 1998 to 10th graders. So, footnote reference is provided there, and you can see it right here. The following 5-variable multiple regression model is specified for this study, and you can see it right here. So it's 5 variables, the dependent variable y, and 4 explanatory variables, where x1 is the student-teacher ratio, x2 is average teacher salary, and let's make sure that we don't have too many apostrophes there, and x3 is median household income, and x4 is percentage of single-family household. Now then, pursuant to the purpose of this study, the regression null hypothesis is shown here. Now remember, the purpose of this study, if I may scroll right back up here, is to investigate if a relationship exists. So this type of multiple regression study requires that your null hypothesis be a hypothesis for the entire regression, whereby it's a null hypothesis that all of the coefficients are equal to 0. Because if any of them is not equal to 0, then you would reject the null hypothesis. Now then, the data set for the study is presented in Appendix 1. Before the facts, it is expected that x1 and x4, let's push this back up a little bit, will have a negative impact on student performance. x1 is student-teacher ratio, and x4 is percentage of single-family household. So in essence, I'm saying here that as student-teacher ratio goes up, student performance will go down. Likewise, if the percentage of single-family household increases, student performance would also go down. Why? Well, this is part of a process whereby the researcher injects a little bit of his or her views before the facts, and then you proceed with the inquiry to determine whether those views hold up. So here I write that a high student-teacher ratio x1 suggests a less individualized attention in the classroom. In the same vein, a high percentage of single-family household might limit the extent of the type of comprehensive family care from both parents, which many believe is essential in the wholesome growth and development of a child. Now then, here I also write that the impact of teacher's salary and household income X2 and X3 respectively is expected to be positive. So now, why? A high teacher's salary may serve as an incentive for a more effective teaching in the classroom in that the teacher is better motivated. So this is the age-old expectation that the more money you pay someone, the harder the individual would work. It is also arguable that households with more disposable income are more likely to be able to provide their children with better and/or additional learning support, which may include private tutoring, electronic learning devices such as computers and iPads and other kinds of tablets, and importantly, a quality of life in which the negative impact of poverty on the emotional well-being of a child is eliminated. So now, with that, let's go to analysis and results. It says here, present a summary of your final results. Be sure to show a summary of the results of any transformations you have performed. Also, provide a brief background of the results. And are the results consistent with your expectations prior to the study? Now again, a quarter of a page, half a page should be plenty out here. All right, although I'm writing a maximum of 1 page. So right here, for my analysis and results, said regression results are summarized in table 1 below. And so for the analysis to be carried out, I'm going to go here to the spreadsheet. All right, looking at my data right here, let's just copy it and go to a clean page like so. And for this regression analysis, I would go to data and go to data analysis and go down to regression, click on it, OK, move this aside, and while cursor is blinking there for input Y, I click from the word score. I can't have 2 cells containing text, so from the word score all the way to the bottom, and then click here for input X range. Let me drag this up to the top and get all of these all the way to the last row. Check labels here so that the computer knows you have text on the first row of cells. And then check here for output range and click right there. While cursor is blinking there, I'm going to go to the bottom of the file like so. Click right there and check residuals because we're going to do some residual analysis. So then click OK, and that's your output. And I already have mine done quite well right down here. All right, so what I'm now going to do is to summarize this, and when I do so, you see it right here. All right, so I note, so you can see here my coefficient of determination R-squared is about 0.62. F statistic is 88.4 approximately, and the p-value means that this F is statistically significant. And so here, if I go up, I write here that the F statistic of 88.37 with this p-value indicates that the regression as a whole is statistically significant. The coefficient of determination R-squared suggests that about 62% of the variation in student performance is explained by the 4 explanatory variables. All right, move this down so you can confirm again what the R-squared is. In the absence of any significant residual problems, the prediction model would be specified in this way. This is going to be a prediction equation right here. So where this is the intercept 231.89, that's it right here, and negative 0.496 is this coefficient for x1, and negative 0.023 is this coefficient for x2 right here, and 0.293 is this coefficient for x3, and finally negative 0.878 is this coefficient here for x4. So that's how you have it finally. Now then, how about these out here, the test of significance for the independent variables measured by their t-statistics, that's right here, shows that with the exception of teacher's salary, x2, all the explanatory variables are statistically significant. So as you can see here, based on their p-values, they're all statistically significant. We typically don't pay much attention to the intercept though, so we're more concerned about these right here. So these are all significant with the exception of this guy right here. The signs, well, in other words, right, continuing to read here, they contribute meaningful information in the prediction of student performance. The signs of the coefficients for the independent variables are also consistent with prior expectation, with the exception of x2, which nevertheless is not significant. So as you can see, yes, x2, which is teachers' salaries, which we believed should have been positive, is negative, but nevertheless, as you can see here, it is not statistically significant. So taking the value of the coefficient for x4, for example, which is this value right here, it suggests that the average student score decreases by about 0.88 for every percentage increase in single-family household. Notice, this is also statistically significant. So we're done interpreting our results, but we need to do a few diagnostics here. One of which is multicollinearity, because this sign doesn't quite look logical to us, and in any event, its t-value is not significant. So that begs the question as to whether multicollinearity is present, and here's how I address it. Often, when collinearity exists, the sign of the regression coefficient is the opposite of what logic suggests. In this case, the more money you pay teachers, the more effective they will perform, and therefore the higher should be student scores. Also, the t-value may not be significant even when the f is significant. As you can see, the t-value for this coefficient is not significant even when the f value is significant. Now remember, everything I'm saying is based on an ex ante opinion. It's not backed by rigor yet until we are done with this analysis. So in any event, to confirm that the lack of statistical significance and illogical sign associated with x2 is not due to multicollinearity, the correlations between the independent variables are examined. And here I present the correlation half matrix. So to do the correlation matrix, what you would have to do would be simply to go to data again, data analysis, and go up here, check correlation, OK, and then highlight all of these, only the independent variables, because you wish to determine whether these independent variables have any kind of near linear relationship themselves. And let's just place it right there. OK, so that's it, and the summary result is copied over here. So let's interpret this. All right, I've highlighted two suspicious numbers. The correlation coefficient between teacher's salary and household income. Teacher's salary, household income. That's the correlation coefficient here. Is 0.55, which may be considered high. Even larger is the correlation coefficient between household income, x3 right here, and the percentage of single-family household, x4 right there. So that's the correlation right here, which is about negative 0.62. Keep in mind, the correlation coefficient ranges from -1 to +1. Now, this is, however, a casual observation. A more rigorous analysis of multicollinearity is based on the calculation of the variance inflation factor for each of the variables in the model. So, and this is how we define the variance inflation factor, and to obtain this data, we would have to run a regression of x1 against the other independent variables, do the same for x2, for x3, and for x4. And right here on my spreadsheet, this is how I carefully arranged my data. So in the first regression, I'm going to regress this yellow column of data, x1, against x2, x3, and x4. and do the same for x2 against 1, 3, and 4, and do for x3 against 1, 2, and 4, and finally x4 against 1, 2, and 3. When I run the regressions, which you should now be able to quickly perform, these are my results. When I run x1 against 2, 3, and 4, this is the result that I get, and then I calculate the variance inflation factor, which is simply equal to 1 divided by, open parenthesis, 1 minus r squared. This is your r squared right there, and close parenthesis. So that's how I get this 1.2. In the same way, when I run a regression between x2 and the rest of the other independent variables, I get this, and then I calculate VIF, ditto for x3, and finally for x4. This is their summary, which I now copy over to Excel, to Word, and you see it right here. So I interpret a high VIF means that the variance and therefore standard error of the regression coefficient is inflated, so that the corresponding t-value is less than it should be. A helpful rule of thumb is that collinearity exists if variance inflation factor is greater than 5. Well, as table 3 shows, the highest VIF is 2.25, which is this, obtained from with respect to x3, meaning that the variance of b3, which is the coefficient of x3, is only 2.25 times what it should be if collinearity did not exist. This highest VIF is too small to cause us concern. With this finding, one can conclude that collinearity is probably not a problem in the model. So that's how we've cleaned that up. Now finally, we need to do something about testing for heteroscedasticity. As you know, we're using cross-sectional data, and often we may have this case of unequal variance. If you were using time series data, you probably shouldn't be bothered so much about the problem of heteroscedasticity. I would recommend that if you're using time series data, that you be sure to perform a check for residual correlation using the Durbin-Watson test. So here, for this test, I write that heteroscedasticity is the problem of unequal error variance and is typically encountered with cross-sectional data such as this. When heteroscedasticity is present, the regression coefficients are no longer efficient. And continuing here, I write that the Goldfeld-Quant test is a rigorous way to test for the presence of heteroscedasticity, which by the way may be spelled with a K or with a C. However, a casual and often effective means to see if this problem exists is the residual plot. If heteroscedasticity exists, the plot will tend to spread out as the values of x, or y hat in the case of multiple regression, increase. This means that as the values of x become larger, there is increasing uncertainty associated with the response of y. So here, the plot is summarized in figure number 1, as you can see. And this is why, if I go back here to the spreadsheet, go to the original data set, this is why it was helpful for you to check residuals, because by checking residuals in that dialog box in data analysis, you'll get this output. The computer will give you this output. The output includes y hat values, which is the predicted y value, and the residuals. And all you have to do is highlight these two columns of data and go to Insert, choose Scatter, and choose the first one here, and you're done. You can remove the legend. That's it. So I explain, while the scatter of residuals appear more robust in the midsection, as you can see up here, of the graph than at the beginning, there is no definitive indication that heteroscedasticity is present. Nevertheless, so as you can see, what essentially I'm saying is, okay, I see that things look a little bit funny out here. However, it may all still be white noise, and therefore it's not quite so definitive. Nevertheless, I write here that a popular and often effective variance stabilizing transformation is the logarithmic transformation of only the values of y. So by taking the natural log of y and regressing it on x1, x2, x3, and x4, we might be able to clean out any heteroscedastic problems if in fact we have it. So all I've done here is to transform the values of y score to natural log, and to get this all I did is equal ln, that's the function for natural log. Click on this, close parenthesis, and then copy it down like so. That's it. And then when I'm carrying out the regression for my y, this is the column that I would highlight for my y, and the x independent variables will remain as is. And when I do that, I get the outputs that you see down here. And the residuals associated with that look pretty much the same, pretty white noisy in nature. So the summary of it is what you see right down here. The regression results of this transformed model, I note here, are summarized in Table 4. These results do not show a marked improvement over the original model. The coefficients have the same manner of statistical significance as before. Also, the value of the coefficient of determination is virtually unchanged. So as you can see, well, first of all, the f is still significant, and also r squared is about the same. It's about 62%. If I go back up here to table 1, you see it here, it's about 62%, so that's the same. Also, you're going to see that teacher salary x2 has the same manner of sign and values, as you can see right here. It's still not significant and it is still negative. So really, I doubt that there are any heteroscedastic problems in the model, because when, as you saw in the residual plot, that actually did not appear to amount to any hill of beans. So with this outcome, the final prediction model is based on the original non-transformed model. So if I go back up here, this is the original non-transformed prediction equation right there. So finally, it says here in section 4, conclusions and study limitations. To brief for my conclusions, I write as follows: that this study examined the relationship between student performance in grammar schools and a set of socio-economic factors. Student performance is measured by the mean score on the Massachusetts Comprehensive Assessment System, MCAS, administered to 10th graders. Results show that student-teacher ratio, teacher's salary, household income, and the percentage of single-family households as a whole affect student performance. Altogether, they account for about 62% of changes in the mean student's assessment score. More specifically, there is evidence that student performance rises with household income on average. On the flip side, there is also evidence that performance is hampered by a high student-teacher ratio as well as by a high incidence of single-family households. And then if you wish to use the model as you have it to predict what student score would be given these projections right here, it'll come out to give you this result. So in the final analysis with respect to any study, any limitations and improvements, in particular improvements, here's what I've addressed. I said an important improvement to this study is an investigation of how the study time spent by students outside of school and the level of education of the students' parents, and maybe we need just one apostrophe there, might affect performance. Because of the widely publicized disparity in performance across ethnic lines, it may also be helpful to determine if, after accounting for all the above factors that I've named, in addition to these two here, there is still a difference in performance between the various racial groups. This latter inquiry can be pursued in a comparative study. So that's basically what I have as far as this study is concerned, and it notes here that your report should be prepared in Word, as I've done, that you may initially prepare your results tables on spreadsheet and then copy them over to your main Word file, as I've also demonstrated. It says do not include your data set in your report because it's just going to clutter it. Alright, you may place it in the appendix, but you don't really have to print it. And finally, you will be graded on these three criteria right here: the correctness of your model specification, interpretation of the regression model itself, the analysis you've performed, and the results that you've shown. And then importantly also the clarity of your overall research writing. So try as much as possible to be brief, straight to the point. A couple of sentences suffice as far as this project is concerned. Hope you enjoyed it. This is Pat Obi, Purdue University, Calumet.